Hi there, folks. Today we're looking at factoring by grouping. And factoring by grouping is really just doing the greatest common factor more than once. All right. So if you remember, the greatest factoring at the greatest common factor was like undoing the distributive property. Instead of multiplying in, which is our distributive property, we're dividing out. That's what factoring is. But factoring by grouping, we essentially just do that more than once within the same problem. All right. So factoring by grouping, we're going to put the terms in groups using parentheses. And for our purposes, it's going to be groups of two. All right. So groups of two for these groups using parentheses. So groups of two. All right. Then we're just going to factor out the greatest common factor from each group. I'm essentially just going to look at the first set of parentheses and say, okay, let's do what we've done in the past. Let's factor out the greatest common factor. Let's undo the distributive property. Then I'm going to look at the next group and do the same thing. All right. And if there's another group, I'll do the same thing to that group. So I just go to each group and do the thing that I'm used to. I factor out the greatest common factor. And then in the end of that, we're going to look for common polynomials. We're going to look for big chunks that are the same so that we can rewrite this thing as maybe a set of binomials or a binomial and a trinomial, that kind of stuff. Okay. And that last step might be a little strange at first, but it's one that's very easy once you start to recognize it. Okay. For example, if we look at something like this guy, again, I'm going to put these in groups, and I'm going to do groups of two. So here's my first two terms. I put those in a group using parentheses. And then I go to my next two terms, and I put them in a group using parentheses. And yes, I did something a little strange there. I included that plus sign in front of the two right here. Okay, that ends up being very important, not really in this example, but in any example where there's a minus sign. We have to be very literal about the sign that we're using there. So we want to include that in the parentheses. All right. So now I'm just going to factor out the greatest common factor. If I were to ignore that second group, if I just had this first group, if I gave you this question off to the side here and said, hey, factor out the greatest common factor, you'd go, oh, well, between a 3 and a 12, the biggest I can divide out is a 3. And between n to the third and n to the second, the most n's that I can take out of each of those before one of them runs out is an n to the second. And remember, we're dividing out. When we divide variables, we're subtracting the exponent. So we think of it like we're taking it away. And when I do that, 3 divided by 3 is a 1. Here, when I subtract the exponents, I'm left with an n to the first. Here, 12 divided by 3 is a 4. When I subtract the exponents, I'm left with a 0, so I don't have any n's left. And of course, I could clean that up a little bit. It would be this. All right? But instead of doing that off to the side, let's bring it back over to the original problem. So out of this first group, I factored out a 3n squared, and it left me with an n minus 4. Okay? And now I kind of do the same thing, but with the second group. So let me erase this. I'll take this off to the side. We won't normally take it off to the side, so I'm just doing that to kind of show you in this example so we can isolate it. We'll just isolate it in our brain next time, all right? So here, the greatest common factor is a 2. That's what divides evenly into each of them. The second one doesn't have an n, so I can't take any n's out. But when I divide 2 divided by 2 is a 1. 8 divided by 2 is a 4. And again, if you clean it up a little bit, we took a 2 out, and we were left with an n minus 4. And here's the important thing. I have to note that the 2 I took out there was a positive 2, so I put a plus 2 here. Okay? If I factor out a negative 2, I have to put a minus 2 there. And really, most of the time, what I do is whatever this sign happens to be, that's what I'm going to factor out. If that's a plus sign, I'm going to factor out a positive. If that's a minus sign, I'm going to factor out a negative. Okay? So just be aware of that. And now look at the big chunk they have in common. See the n minus 4 that they have in common? So they have an n minus 4 in common. So basically, if I kind of undo the distributive property, that was an n minus 4. And you see what's being distributed to the n minus 4? Here I'm distributing a 3n squared, and here I'm distributing a plus 2. And the way that we distribute two things is to have a polynomial with those two things. In other words, a 3n squared plus 2. See, it's me essentially undoing this process. All right, so if I think about this backwards, let's think about when we multiply these two things. Like if I had 3n squared plus 2 and the n minus 4, remember the first step for distributing this thing? I would say, hey, I take this first guy, the 3n squared, and I'm going to distribute that to the n minus 4. And then I take the next guy, the plus 2, and I'm going to distribute to the n minus 4. And so what I've done in this last step to get from here to here is I'm doing this step backwards. I'm saying, hey, what I have here is a 3n squared and a plus 2 being distributed to an n minus 4, which means I have a 3n squared plus 2 times that n minus 4. I'm undoing that step. And if I were to continue this process in the parentheses here, that's a 3n cubed. Remember, I add the exponents. Minus 12n squared plus 2n minus 8. But hopefully you see that this is the same 3 steps, but backwards. See here, if you look at it, step 1 over here is step 3 over here. Step 2 over here, step 2 over here, and step 3 over here is step 1 over here. Okay? It is the same 3 steps, but in reverse order. We are undoing that original process, all right? And if you haven't noticed by now, that is a very common theme in math. When we solve equations, we are going backwards through the process of order of operations and undoing the stuff as we go. When we factor, we are undoing the process of multiplying and doing our distributive property, and we're undoing those steps as we go, okay? So keep that in mind. So here's my factored form. It's just us working backwards, okay? Multiplying brings us to that original type of problem. So this is undoing that multiplying process. Let's do another one. We'll do a little less off to the side this time, okay? So with this one, the first thing that you might notice is that there's a greatest common factor between all of these, okay? There are 2 ways to do this problem. You can either factor out the greatest common factor first, and if you notice, they all have a 4 in common. So I could take that 4 out, which leaves me with an x cubed minus 2x squared plus 3x minus 6. Okay, so I factor out the greatest common factor. Now let's put the what's left in groups. All right, so I put these in groups. And really, that 4 on the outside, he's just going to tag along for the ride the whole time, all right? He's boring. He's just going to stay out here, and we're just going to deal with the rest of this problem. So if I look at that first group of parentheses that I have there, that green set of parentheses, between an x cubed and a minus 2x squared, the only thing they have in common is the x's, and the most I can take away before one runs out is an x squared. So I divide out the x squared, so I subtract the exponents. That's x to the first minus 2. If I look at the second group, I can factor a 3 out, and I want it to be a positive 3, so I'm going to write a plus 3 here. And when I divide each of these by a positive 3, it leaves me with a 1x and a minus 2. And now can you see that what I have is I have this x minus 2, and it's being, what I'm doing is I'm distributing an x squared and a 3 to the x minus 2, which means this has to be an x squared and a plus 3. And now just cleaning up a little bit, I don't need all of those parentheses. It's 4x squared plus 3 and an x minus 2. Okay? And here's the thing. If you don't recognize the greatest common factor at the beginning, that's going to be okay for this one. If you go right to grouping it, watch this. Out of the first group this time, I can take out a 4x squared, which leaves me with an x minus 2. Out of the second group, I can factor out a 12. It's got to be a positive 12, which leaves me with an x minus 2. And now the 2 factors, let's see, it's an x minus 2, and I'm distributing a 4x squared and a plus 12 to that x minus 2. And see, I don't quite have the same thing, but that's because there's still a greatest common factor in this first group. That first group, I can take a 4 out of that first group, which leaves me with, sorry, that's not a very good parenthesis. I can do better. I believe in me. If I take a 4 out, that leaves me with an x squared plus 3. And then I still have the x minus 2. Now I have the same thing. Okay? My recommendation is to always look for the greatest common factor first and then factor what's left. All right? Even though it seems like that right-hand side might look a little more difficult, it will save you some work in the long run, I promise. Okay? If I look at the next one, once again, There is a greatest common factor between all of these. I could factor an x out of each of them. So I just set up a big set of parentheses or brackets here. So that leaves me with a 3x to the third plus 9x squared minus x minus 3. Remember, when we divide out a variable, we're subtracting the exponent. So I'm taking an x away from each of them. Now let's factor by grouping. Let's put these guys in a group. Let's put these guys in a group. All right. And again, it's really important to include that sign. Now this x is just going to tag along for the ride. We don't really care about him. He's just going to hang out here. Draw on the next couple steps. Out of that first group, they have a 3 in common. And then the most I can take away in terms of the x's before one runs out is an x squared. So that leaves me with an x and a plus 3. Out of the second group, the only thing they have in common is a 1. But this is the situation. See, factoring by grouping, you have to factor something out. So I have to factor out that 1. But because I see a minus sign here, that's a clue to tell me to factor out a negative 1 instead. And now negative x divided by negative 1 is a positive x. Negative 3 divided by negative 1 is a plus 3. Okay? So I just have to be really careful with my signs here. Now I can see that what I have is I've got an x plus 3. And I'm distributing a 3x squared minus 1 to that x plus 3. So that's my other factor, 3x squared minus 1. Okay? And now, of course, I would probably rewrite it like this without the little brackets. 3x squared minus 1 and an x plus 3. We're undoing the distributive property. Okay? If I look at this guy, again, 4 terms, there's no greatest common factor here, all right? So this is one of the easier type of examples, so I go right to factor by grouping. Ready? I put these guys in a group and put these guys in a group. Out of that first group, they have a y in common, so I factor a y out. That leaves me with a 3y plus 5. Remember, I subtract the exponents when I'm dividing by variables. Out of the second group, they have a 2 in common, so I do a plus 2. And yes, it's a positive 2 this time, so that leaves me with a 3y plus 5 when I divide it out. And now look at this. I have a 3y plus 5 in parentheses, and to that 3y plus 5, I'm distributing a y and a plus 2. So my two factors are the y plus 2 and the 3y plus 5. I'm undoing the distributive property. Okay? If I look at the next one, same kind of thing. There's no greatest common factor. I go right to factor by grouping. Put these in groups. Out of the first group, they have an x in common, so I pull an x out. That leaves me with a 2x plus 3. Remember, you subtract the exponents when you divide. Out of the second group, they have a 2 in common, but look at that. It starts with a minus sign, so let's factor out a negative 2. And just be careful with your signs. When you divide by a negative, it changes the sign. So here, when I divide out a negative 2, it leaves me with a positive 2x and a plus 3. And so now I can see a 2x plus 3 in each of those parentheses, and I'm distributing an x minus 2 to that 2x plus 3, so that means I have an x minus 2 times a 2x plus 3. I'm undoing the distributive property. If I look at this one, same kind of thing, factor by grouping. I'm going to put these guys in a group. I'm going to put these guys in a group. Out of the first group, they have an n in common, so I can factor an n out. So that's an n minus 4. When I take those n's away, remember, when you divide, you subtract the exponents. Out of the second group, they don't really have anything in common, but there's always one thing I can always take out, and it's a 1, and this time it's a positive 1. Normally, we don't factor out a plus 1, but in factoring by grouping, we have to. So it leaves me with an n minus 4. Now I can see the n minus 4 in each parenthesis, so I'm taking an n plus 1. I can see an n plus 1 being distributed to an n minus 4. So there's my two factors. I'm undoing the distributive property. Okay? And really, there's something kind of special about these last 3 examples. Here's the last 3 examples we just did. See, the last 3 examples we just did are interesting because This guy has like terms. Normally, this one would be written like this, 3y squared. Look at those middle terms. They combine into a plus 11y. Look at this next one. Again, those middle terms are like terms. Normally, we would write this as a 2x squared minus x minus 6. And then look at this last one. Same thing. There are some like terms here. Normally, I would write this as an n squared minus 4n plus n minus 4. Okay? Oh, sorry. Minus 3n. I forgot to combine the like terms like a crazy person. Get your head in the game, Mr. Jansen. And see, that's interesting and significant because how in the world did I know to rewrite this guy like this? How did I know to rewrite this guy like this? How did I know to rewrite this guy like this? That's something we're going to learn in future lessons. We're going to rewrite, remember these guys 3 terms, that's a trinomial. We're going to rewrite those as 4 terms so we can factor by grouping, okay? So keep that in mind. That's something that's on its way, all right? So how might this help us factor other polynomials? Well, factoring by grouping works really well with 4 terms, but you can see how it wouldn't work well with 3 terms. We're going to learn how to factor by grouping with 3 terms by rewriting it this way. Okay, so keep that in mind. That's something that's on its way. But factoring by grouping is just greatest common factor twice. Let me scroll back up to some of these. Okay, we put them in groups of 2. We factor the greatest common factor out of each group. And then we look for that common thing in parentheses so that we can see what our 2 factors are supposed to be. We can see what our 2 binomials are supposed to be. Okay, what is being distributed to that binomial? And then we can separate it out. We can undo the distributive property to come up with our 2 factors. Okay?